Hello and welcome everyone for today's sessions. I welcome all those people who joined today's sessions. This is our fifth sessions on AZ-400 track. And those who missed this previous session for AZ-400, they can watch that on AzureTalk YouTube channel so that they can cover the complete track for this exam. Now, we are conducting these sessions to help people learn certification based courses and appear for the exams, which is a Microsoft exams. Before AZ-400, we have delivered sessions on AZ-900 as well as on AZ-104s, which are Microsoft certification based exams. So 900 was for fundamental, 104 was for administration track. All these sessions are possible with the several Azure Easy, AzureTalk core team member who are helping with delivery, content and all. Without these people, these sessions would not be possible. So let me introduce all those core team member. Myself is Vipin Jha. I'm an MCT. I do trainings for Microsoft technologies and I do consulting for Microsoft things, specifically Azure Cloud. Then we have Ram Murthy. He's also an MCT and he's an Azure architect. Then we have Ashish Raj. Ashish is a DevOps architect and he's also an MCT. And he would be the today's speaker as well. Then in our AzureTalk core team member, we have Shri. Shri is a cloud solution specialist in multi-cloud. Then we have Kirtika Gupta. She is a cloud engineer and she helps as a backend team and delivers several sessions in Azure Easy as well. Then we have Nitanshu Sharma. He is also an MCT and a cloud consultant. So these all are the Azure Easy core team member who help delivering the sessions, building the sessions and all. Now let me introduce our today's sessions speaker. So we have Ashish Raj. So Ashish would be delivering today's sessions, and for this AZ-400 track, he is the primary speaker for all the sessions. Then we have Sanjeev Panigadi. He is MCP and senior software engineer. He would help us in demo sessions in today's delivery. Post this for all these exams, all the people who are appearing for these sessions, they have a chance that they can win the free exam vouchers. So for all the sessions that we have conducted previously in AZ-400 track, okay, we have a quiz sessions at the end of the delivery. So if you appear for that quiz, we have a lucky draw system and all the people who appear for this exam, based on that lucky draw, there are 6 people selected and they can win the exam vouchers. Now to get this exam vouchers, you must have registered for all the sessions for AZ-400. So we have total 8 sessions on AZ-400. So you need to register on all those sessions. Plus, for today's quiz, we will announce the winner in the next sessions. So in every quiz, what we do, if we are paying for the quiz today, in the next session, we will announce the winner. So today we are going to announce the winner for our previous sessions. And for today's winner, we will announce it on the next sessions. Our next session will held on 6 February 2021. Now, we get a lot of messages and lot of recognitions and appreciation from the people. Lots of thanks note that based on these sessions are helpful for the people and they are able to appear for the exams and all. So if you feel like these sessions are helping you learning this Azure DevOps and you are able to appear for the exams in any way, in that case, for all your social media messages, LinkedIn and all, you can hashtag AzureTalk and Azure Easy so that these hashtags can help the other people to learn these respective things. Now, continuation to this particular sessions. Now I will hand over to Ashish Raj, who will help you on this DevOps certification path and take over today's sessions. So welcome Ashish and take over to you.
Yep, thanks, Vipin, for the nice introduction. Okay, thank you everyone for joining the session today. And today we are going to cover the next module in the AZ-400 exam, exam certification exam. Uh, just like we have been covering all these different modules. So before we proceed to the current, for the today's agenda, we quickly go ahead and briefly talk about the certification path we are talking about. So the certification path that we are talking about is AZ-400. Designing and implementation Microsoft DevOps solutions. So the current solution, the current training that is going through is covering all the topics that is part of this exam, AZ-400. Now, if you want to be certified, then you have to have one of the prerequisite, that is either Azure Administrator Associate certification, which is AZ-104, or AZ-204, which is Azure Developer Associate. So if you have any one of them, then, and if you are taking AZ-400, then you get a certification and a badge from Microsoft, that is Microsoft Certified DevOps Engineer Expert, which is expert level exam, expert level certification. Now for AZ-104, we have already covered a training, and if you go through our uh, uh, YouTube channel, then you will be able to find the playlist where we have covered all the modules that is related to AZ-104. Now, in continuous to that, we are covering this designing and implementing Microsoft DevOps solutions, which, if you are covering, if you are going through both the exams, then you will be able to appear for the exam and you will be able to get the certification, which is Microsoft Certified DevOps Engineer Expert. Now, let's go ahead and talk about the skills that will be measured for that exam, which is AZ-400. So there are various, modules in this exam, which has, different proportion of exam questions, which are to be covered, in our various sessions. So far, we have covered, four sessions, and this is our fifth session. Uh, in today's session, we will be covering this define and implement a continuous delivery and release management strategy, which covers 10 to 15% of your exam questions from the questions point of view. Prior to that, we have already discussed about continuous integration, source control, and communication and collaboration, the previous modules, which covers different proportion of the exam questions. And we have already hosted our previous session recordings on our YouTube channel. So you can go there and you can watch the previous sessions if you have not watched it yet. And then today's session, we are covering this. And in upcoming sessions, we will be covering the next modules or the next exam, the topics, talking about instrumentation strategy or site reliability engineering or security and compliance plan. That is that all these topics will be covered in our upcoming sessions. Now, let's talk about today's agenda. So today we are going to cover, the first thing that we are going to cover is develop deployment script and template, which is exam topic. There we will be talking how do you, how do you actually develop your deployment strategy? How do you kind of use different tools, different strategy to deploy solutions once you have completed your continuous integration? After that, we will be talking about orchestration automation solutions. So when you deploy things, when you put things, when you are deploying solutions on an infrastructure, then maybe you want to orchestrate all the settings, all the different types of resources that you want to deploy. So what are the various options? What are the various things that you may need to take consideration of? And the third thing that we are going to cover is plan the deployment environment strategy. So how do you plan your deployments, how do you plan your environment for the deployment? We'll be talking about all those things in the last section. Now let's talk about the first thing, which is develop deployment script and template. Now, when we have our continuous integration, which is essentially getting the artifacts. So we have already discussed that how do you actually have your uh, source control, which is your code, and you put your things here in CI, which is continuous integration, which takes a couple of steps, and then it generates a package which is called artifact. Now, when you have this artifact, then you can decide upon, either automatically pick it from here and do certain things, certain things to deploy it on the server. Now, these steps can be manual, or these steps can be dependent on certain things, maybe a management approval or certain things. Now, after getting the artifact, how how these things works after that, how continuous integration does not guarantee that you will be having the updated code on the target server as well. This is not, continuous integration enables you to continuously build your code, which is there. As soon as you get the latest code, if you have configured your continuous integration, we have already talked about various options there. You can enable the triggers, you can do certain things, and then whatever the steps is required to create the artifact is nothing but some exe file, or maybe some zip file, or maybe it can be aspx file, or maybe it can be msi file, whatever can be taken further to deploy it to the actual server or to the actual file system, or wherever from wherever it can be consumed by the user. So this is what the artifact. Now, when you talk about after CI, you get two things. One is continuous delivery. Continuous delivery is that as soon as you get the artifact, all right, you got to you got to decide whether you want to go ahead and deploy it, or you want to go ahead and deploy it in a dev environment, then probably evaluate it using manual testing or any kind of validation, and then probably you will, after the evaluation, you may be taking it further to the another environment, which is staging or maybe the prod. So if at all you got to decide upon these things, that's what you are getting the continuous artifact, that is continuous delivery. You are getting the packages getting generated automatically continuously, but you are not deploying continuously, because you got to evaluate something in terms of the the resources it may need, the validation it may have to go through, all those things. So continuous delivery talks about that once you have the package, what exactly you can do. uh, do you need to have the approval? Do you need to have the approvals here? Do you evaluate in dev and then only you go to QA, or maybe do you evaluate in QA and then only you go to pre-prod? So even though you are getting the latest updated builds, you are getting the package 1.0, 1.1, 1.2 package is there, but you are not deploying. It is not consumed yet in the production on the server. That's where you got the continuous delivery. Now, there is another term that is also stands for CD only, that is continuous deployment. Now, let's go to the next slide. If we go to the next slide, the only difference here is that the whole thing is auto approved. So if you have all these things automated, as soon as you get the package 1.1, you got the steps to execute in dev, and if validation pass, that is automated, then it goes to QA. Then if it validates properly based on some automation tool, some kind of automated matrices and all, then it goes to the another environment which is pre-prod, and then again you are doing all those things, all the validation, all the things using automated way. And if it is going to production, as soon as package 1.1 is available, it is continuously getting validated and continuously getting deployed. If it is correct one, then it is called continuous deployment. So continuous deployment is increment on top of continuous delivery. So continuous delivery guarantees that you get the package because CI is continuously running and it is able to generate the package based on the task that you have configured in CI. And continuous deployments enables you to automatically deploy these packages on the server, continuously. That is why it is called continuous deployment. So CD stands for continuous delivery as well as continuous deployment. There is a very a simple change or simple difference between continuous deployment and continuous delivery is that continuous deployment guarantees that deployment is going to happen automatically as soon as new package is available from the CI system. Now, when you want to apply these things, when you want to implement these things, there are certain tools which can help you to do that. One of the very useful tool that is coming from Azure DevOps services, which is called Azure Pipelines, and we are going to explore this Azure Pipelines. We have already explored Azure Pipelines for our continuous integration. Similarly, we are going to further explore this during our demonstration lab. There we'll be talking about what are the various options there. You can explore when you are putting your things there in the deployment. Similarly, you have GitHub Actions that is coming from GitHub. So you can write GitHub Actions in YAML file, and then you can actually deploy things over cloud, including Azure, or on-prem, or there are tasks available there. Based on the tasks you select, you can do the deployment based on the CI pipeline that you have. Similarly, one of the famous tools for continuous integration and also useful for continuous deployment is Jenkins. So you can use Jenkins for implementing CI and CD framework. And similarly, one more tool that is there is Octopus Deploy. So Octopus Deploy is another tool that is coming from a company Octopus, and then you can actually configure Octopus Deploy to deploy your packages which is coming out of continuous integration to the deployment targets, including on-prem servers and as well as to the cloud servers. Now, Azure Pipelines do give you integration with Jenkins, with Octopus Deploy, and as well as GitHub. So GitHub Actions and Azure Pipelines are in some way are parallel things, but Azure Pipelines gives you a way to integrate with Jenkins. So if you are doing certain things in Jenkins and if you want to do certain things in Azure Pipeline, that is supported. Similarly, if you are using Azure Pipelines for doing the continuous integration and you want to deploy, using Octopus Deploy because of its features which are very much uh, as expected for your organization, very much useful for your organization, you can use combination of these two tools. So those kind of extensions are available with these tools. So these are the few tools that you can use to implement these kind of continuous deployment and continuous delivery. We'll be looking into these things in Azure Pipelines. Now, similarly, when we talk about continuous deployment, we have to talk about continuous infrastructure as well. Now, what do you mean by continuous infrastructure? So as soon as you have your application, suppose you are getting your CI run and it is getting your package 1.0 and then 1.1 is coming. Now, suppose this 1.1 requires certain things, certain changes there in the infrastructure. Maybe it is Azure, one of the resource in Azure, or maybe one of the setting in on-prem, or maybe one of the configuration of the server itself. So when there is a change in package, it expects something to be changed on the server as well. Now, if you go through the traditional way of handling the infrastructure changes, then what will happen is that as soon as you have the 1.0, then you will have to raise a kind of a ticket or kind of a report it to the infrastructure team, and they will manually do those changes, and that's how it works normally. And then as soon as they will implement these changes, they will tell you that okay, it is done now, 1.1 can be deployed on the server, and then you will trigger the release, that is continuous deployment, and then it will deploy. But during all these times you have to wait, right? You have to wait for the infrastructure team to do that. What if we can do this changes as well using code, right? I mean, if just like we have the CI configured using some Git, right? I mean, whatever the changes we are implementing on the application, we are implementing on Git, and then as soon as there are changes on Git, it runs the CI, and then similarly it generates the package. Similarly, what if we do the we do the infra as well in the Git, you know, in some kind of code or some kind of script, and then as soon as we have the changes, we can have a CI pipeline. We can do the which can either generate a package or maybe directly make the changes into the server, so that it will be also a continuous kind of thing. So this way of doing things is known as continuous infrastructure. So what you can do is you can create your infrastructure or define your infrastructure using some script. Some examples are ARM template. You must have heard it. You can use ARM template to define your infrastructure in Azure. There is something, you know, one of the industry leader in infrastructure as code is Terraform. So you can use Terraform to create your infrastructure in Azure or in other clouds as well. So it is a multi-cloud solution, multi-cloud, as well as, you know, it's kind of it also supports some of the on-prem solutions. So you can create your infrastructure using Terraform, and then what you can do is you can apply certain things because it is automated. You know, it is in terms of Git or in terms of code, you can do some CI pipeline to apply the governance to, you know, automatically make the, you know, changes into the infrastructure using some CI pipeline. You can evaluate what are the things happening on the server and then continuously make changes on the server. You know, server can be in the cloud, can be in Azure, can be other cloud like Google, AWS, but that can be implemented if you are using some scripting technology or, you know, some kind of ARM template or Terraform to define your infrastructure. Now to demonstrate this, this is the demo that we have planned today. So we will be demonstrating how you can get started using Terraform. So in our lab, Sanjeev will be, sorry for that, today I have bad throat. Today Sanjeev will be exploring how you can use Terraform using Azure Pipelines. Now, once you have these things in pipeline, the benefits that you get is you can have your infrastructure deployment, you know, automated. That as soon as some changes are done on the code level, it can be configured with CI pipeline, which is something in Azure Pipelines or Jenkins or any other CI pipeline tool. You can configure it, and based on that you can make changes into the, you know, the respective cloud or platform or infrastructure. It can be Azure, it can be AWS, it can be GCP, or it can be even on-prem. So it is completely up to you the type of application you are using to code your infrastructure. That will define what are the things you can do with that. One of the industry leader is Terraform. So Terraform can help you with implementing infrastructure using code in major cloud, when major cloud providers, major public cloud providers, as well as some of the on-prem technologies. Similarly, if you are using code, then it will be possible for you to version the infrastructure. Just like you version applications. So normally what you do is you have an application requirement like 1, 2, 3. With these requirement, you create a code and you call it like version 1.0. Now, later on some requirement comes in like, as a requirement 4, you add that that feature in the code, and then you call it like version 1.1, or whatever, based on the versioning system that you're following. So you upgrade the version, and then you'll be able to tell people that if you want these features, then you can pick this version 1.0, but if you want these feature as well, then then you have to go with version 1.1. Similarly, you can have the infrastructure versioning as well. If you are following this infrastructure as code model, then what will happen? Just like applications has some requirement, infrastructure also comes with some requirement, right? I need one VM, one public IP, and one load balancer. Now later on, based on the requirements, they may say that, okay, no, actually I need one traffic manager as well, or whatever. So VM is there, public IP is there, load balancer is also there. Now they need traffic manager as well, but this completely this is something different than this requirement. Then if you have this ARM template as a ARM template or Terraform to define this requirement, just like application developer use their versioning system, you can say this particular the ARM template or the Terraform template that defines this infrastructure is version 1.0, and this one is 1.1, which has one more feature. And that way you will be able to kind of reusable component, you will be able to implement certain best practices that is used by many application developers for reusing the component. So here, when you are saying you are adding this thing in the infrastructure as code, you're just adding this thing. This was already done. So you are reusing the component, and then you can further evaluate the coding standard, the modularization, the various things that Terraform and other tools, offers in terms of, if you talk about Terraform, it supports modularization. Similarly, ARM template supports some of the reusable component like nested template, linked template. So all those parameterization variables, all those things you will be able to use as a reusable component, and then it will be very easy for you to to create infrastructure as code on the scale. Initially it requires a learning curve, definitely. This is not the way we have been dealing with infrastructure for in a traditional model, but this is what DevOps talks about. Bring in the best practices from the cross functional technology area, like development and all, and adopt it if it is applicable. So this is one of the example where you can this infrastructure as code can be very beneficial for you in terms of reusable things. Similarly, you can implement immutable infrastructure. What do you mean by immutable infrastructure? So if you let me intellect. Yeah. So if you create a ARM template, suppose you create a ARM template which deploys the entire end-to-end requirement, VM, public IP, load balancer. This whole thing was deployed, and you tag it with a version 1.0, right? This ARM template is already with you as a code. Now tomorrow, due to something on the VM, or something because of some modification by manual process or something, one of the thing is not working as expected. But you have the working code which is capable of deploying the exact same infrastructure. So in traditional world, what you do is you go ahead and debug these VMs or the resources that you have, why it is not working, and then you have to take some time to to kind of fix these things if at all it is not working as expected. But in immutable infrastructure philosophy, what you do is you already have the code, so why to debug this thing when you can actually redeploy the same thing. So instead of mutating this one, you just go ahead and deploy the other replica and forget about it, just delete this one, and wherever it is there is some link or there is some mapping, you update those mappings. So immutable infrastructure, you know uh, immutable infrastructure philosophy says that uh, the infrastructure that you deploy should not be should not be mutable by the manual processes. So if you do not allow any kind of, if you define everything in this ARM template itself, if you do not plan anything manual, then you don't really have to worry about anything that can be missed if you will deploy next time, because you have defined everything in this ARM template itself, or PowerShell file, or Terraform, or or any other tool. And then you will be rest assured that whatever is end-to-end requirement is, it will be deployed using this script or the template that you have. That's how immutable infrastructure helps you to kind of avoid debugging or avoid unnecessarily looking into issues which may happen, which does happen in practice. So you can avoid those things. You don't really have to worry about what are the changes happened. You just delete this one, create a new one based on the template, because you know that this template creates a immutable infrastructure where I don't really have to do any mutation or any changes manually. This is what immutable infrastructure. One of the things is Docker. Docker container is a very nice example of this immutable infrastructure, where you define everything in Docker compose file or Docker file, and then based on that, when you create your image, all right, based on that image, you create the Docker instance. Now, after you create the Docker instance, you normally do not change this Docker instance at all. Anytime anything happens with this Docker instance, you just go back to the image and say that, okay, create another one. Forget about this one. Then so and so forth. If at all you want to change something on the image, you go ahead and make changes into this Docker file, and whatever the source code is there, and you create a new image, and then you say that, okay, create a Docker instance based on this Docker new Docker image. And that is how this immutable infrastructure is applied, or is used with the Docker. Now, if you use this IAC, infrastructure as code, and CAC, that is configuration as code principles, then you also got to be friendly with this SRE practices, site reliability engineering practices. Site reliability engineering does have a dedicated module for this exam, and we will be having a session on that. So we'll be talking about what do we mean by site reliability engineering, if we, all those practices, what exactly this, how this fits into this DevOps ecosystem. Some of the organizations are using this term for, dedicatedly create some department within organization, or maybe some titles for engineers. So how does it map to this kind of thing? In essence, no, in brief, what infrastructure as code and configuration as code allows you to do is manage your infrastructure in the same way the way you manage your application. So you have any changes on the application, you update the code. All right, as soon as you have the code updated, you run some CI pipeline, do packaging, maybe do the CD as well, and then you deploy the changes on the target system. It, in terms of applications, it is a server. In terms of infrastructure as code, it is server itself. It is it is something in Azure, something in GCP, something in AWS, or something on premises, creating a VM, creating a web app, or something like that. So this whole ecosystem can follow the similar kind of patterns that is followed by application teams, and that's how you can automate the infrastructure deployment. And when you automate infrastructure deployment, what you can do is you can align these application team. This is application team and this is infra team. They both are working in the similar fashion. They have the automation which can which can run based on the CI pipeline. They are also working on the code level, and then they can work together to plan their each other changes. Okay, I'm making some changes in the application which requires some changes on the VM level. So they both can work together and they can plan their changes accordingly, so that when application is hitting the server already has been configured with this infrastructure as code with the expected changes. They don't really have to wait for each other. They will be planning their changes. They will be planning, they will be well aware of the changes they are supposed to do, the dependent changes they're supposed to follow. And then during the agile planning, during the sprint planning, they will be communicated that, okay, for this story or for this feature, we are dependent on infrastructure for doing these changes. Now infrastructure people knows that, okay, server has to be changed with these configuration before they can apply these feature one. And then the collaboration will work together on the same tooling, same processes, same flow. And that way the gap, the communication gap that exists in traditional teams, where application team will be automated, they will be having a well oiled CI and CD pipeline, but CI pipeline. But when they are applying CD, infrastructure team is coming there in between, and they are saying, no, no, we are not ready. Our our Azure is not ready yet. We need to create these infrastructure before you deploy this latest application. So those things will be mitigated using this practice. Now, the next section talks about implement and orchestration automation solution. Now, what do we mean by that? As we said, when you are following the infrastructure as code principles, and if you are using the tools like pipelines, Azure Pipelines for automating your infrastructure deployment, you can do the infrastructure and application deployment. uh, you know uh, they can work together. What we mean by coupling them is that infra team and apps team, they can plan their changes based on cycle, based on dependencies, and then they can plan the changes on the dependencies. Like normally application team will be dependent on the infrastructure team for deploying certain things. Suppose this application team is creating some application which should be deployed on a web app. Now, before this app can be run for CD, this app should be ready with certain configuration. This thing will be part of the infrastructure team. So they will be creating this Terraform, and they will be aligning with the app team. As soon as they are about to run their CI or CD, they will already have the applicable infrastructure in Azure, and then this application will be deployed, and then it will be very much continuous, very much smooth operations between these two teams, infrastructure and application. You can manage changes in infra. We have already discussed about that. You can use something like Git. Oops, Git. You can use like pipelines, Azure Pipelines, to automate those deployment or configuration changes. So all these things you can manage, and the tools that you will be using are very much similar, or the practices that you are using are very much similar. The way changes are being done by applications team. The third thing, reduce dependencies. As you see, application team was earlier dependent on infra team to make changes on Azure. If at all it was manual, then it's supposed to take, it used to take a lot of time. Because application team is ready, right? I mean, they are working on code, they have the CI pipeline, and the package is ready. So continuous delivery is there. Package 1.1 is ready. Now they want to deploy it on the prod server. Now prod server has to be ready with the requirement, with the dependencies that is required. Now this infra team is not yet automated all these things, using ARM template or anything. They are not yet done. So what they will do, they will say, okay, give us 1 week time, or maybe 2 weeks time, or 3 weeks time, whatever. By 2 weeks, 3 weeks time, suppose they are asking 3 weeks time based on their the operational requirement, based on the resources they have. If they are asking for 3 weeks time, what will happen? By the time these guys will be deploying these this version 1.0, this app team might come with something 1.1, 1.2, or 2.0, because they might have a 3 weeks cycle of release, or sprint, or they might be doing some bug fixes. Based on that, they might be coming with 1.0.1 itself. I mean, some patches are there. And then if they will say, okay, no, there is something, some needs, some update is there, so don't use this package, please use this one, then infrastructure team will not accept it, because what they will say is, for all these 3 weeks we have been planning for this package, all the testing we have done, all the deployment testing we have done, everything we have done for 1.0. Now you are coming with something else. How do we know what are the changes? It may require some other changes on the infrastructure side which we are not prepared enough. So all these gaps, all these dependencies will be removed if you have a similar kind of practices, such as infrastructure as code and CI/CD pipeline with infrastructure teams as well. And then they will be able to deploy these things on the server, just like they are doing, application team is doing. This ends to better collaboration. As you can see, all these, in all these points, the core philosophy is collaboration. The better you plan, the better you collaborate with each other, the better delivery process it will be. In DevOps, in all the practices that you follow, collaboration is a very key element. If you forget about this particular key element, and if you just follow the machine way or the robotic way of implementing certain practices based on some playbook, or based on some book or guide or something, you are not going to achieve the DevOps adoption or the DevOps maturity in your organization. The key feature that you should be looking at whenever you are whichever practice you are implementing, how better collaboration is going to be after implementing this. Is it going to remove certain communication gap? Is it going to improve certain things which is delaying our processes right now, whether it is CI, whether it is CD pipeline, whether it is CI pipeline, whether it is agile planning, or whether it is testing, whatever it may be. Now, similarly, when you deploy things, you have to design your release. Normally, in any organization, you would not be deploying directly to the prod. You might be following some kind of environment design where you have a dev, then QA, and then prod. Each environment will have a different copy of data, different types of validation, and different types of needs that may be there. For example, your dev environment might be as similar to what prod is, but the data which is loading here in dev might be smaller in amount, so that the whatever the development validation has to be taken, that can be done easily. Similarly, in QA environment, you have certain things which is required for integration kind of a validation, where you need to look at the application just near to real-time environment. It is not real-time environment. It is not exposed to the real users, but it is very much near to real user experience, so that the last stage where when it will deploy to the production, you will be covered with all the anomalies or all the problems that may have arisen if you have deployed directly there. So you may have to design based on the organization, based on the product you are working on. You may have to design your release design. I mean, release, when you are defining your release environment, you may have to create multiple stages. In Azure Pipeline, you can create multiple stages. In each stage, you can have a number of tasks. So in in dev, for example, suppose your application connect to a database. Now this database might be a dev instance, and then it will deploy it, and it is running using the database connection, which is dev, and then whatever the validation a developer supposed to have, he will have it. Then if things are working fine, then it will go to QA, whether it is going through a manual approval flow or whether it is going through a automated validation. That is up to the maturity of the application as well as maturity of the team and the tool you are interacting with. That is based on that. So you can do the testing and validation. Based on the environment segregation, it will be easy for you to do the validation, different types of validation in different stages. In dev, you might be looking at the development specific validations and testing. In QA, you might be looking at from the very near to real-time user experience. And in prod, of course, it is like, prod, it is already deployed or to the actual user. When you deploy things, whether it is dev, QA or prod, it might be possible that you have certain dependent component like databases, like web app, just like infrastructures, or some other applications which are acting as an integration component. So if you have a kind of a requirement where before it goes to a deployment target like server, maybe it can be dev or it can be prod, it can be QA, wherever, but it has to communicate to certain things, some API or some other resources like Azure Web App or something else, whatever it may be. So all these dependent component are properly mapped, are properly connected. That also needs to be taken care during your release design. When you define your release definition, you need to take care of these things so that because when you do the CI, it is all your code, right? So when you do the CI, it is all your code changes, CI, you do the compile, you do the testing, whatever unit testing and all, and it generates a package. It is all your application only. Now, this package might need certain things which, this package is just a component. It might need some more component A, B, and C to work to be available while it is getting deployed so that it can work properly. Those A, B, and C does have to be defined or they have to be make sure that they are covered during the release cycle because they are required as a dependent component. Clean this up. All right, so when you define your progression or promotion from one environment to another environment, one of the things that comes into point is that how do you promote it. Like you have this dev environment, you have this QA environment, and you have this prod environment. Now, these names can be different in different context. Some people may call it stage, some people may call it pre-prod. So it is completely up to the organization and the team what they can call it. I mean, what they want to call it. But essentially, you have some environment, you want to promote it from here to here and here to here. What are the ways you can do that? One of the option is automated release gates. So if at all your applications does have certain requirements such as querying some API, running some script or something like that, you can automate it using release gates that is available in Azure Pipelines as a release gate. We will be showing it to you during our demonstration where you can see that, okay, this is the release gates. Various release gates are possible. You can connect to a ITSM tool, query some tickets. You can run some Azure function app. You can do some query in some tools like Azure Board to fetch the user stories or the work items. So you can do n number of dynamic things, and based on the result that you are getting, you can say that, okay, it is ready for going from dev to QA or maybe QA to prod. So all these evaluation can be automated using these release gates. But having said that, the other option that you have is manual approval as well. So you can do the manual approval as well. So in many cases, it may happen that when you are putting things from dev to QA, it is fine. You know, you can do the automation as well. But when it is about hitting the prod, you may want to have some guy who need to approve it or reject it based on the business requirement. It may be a, you know, because this production is something where users will be impacted. So you may have to have a stringent approval process here. So that kind of manual approval, email approvals can be set in the release definition in the Azure pipeline in and other tools as well. And it can be used to kind of implement this practice where one has to manually approve, then only it will promote the package to the another environment. Unless it is approved, it will not go to the next environment. So this has to be taken care during your release definition itself. You need to plan who this guy will be, what are those automation things are. You know, do you have a AZ function app, or do you have a script, or do you have a query that you want to run against Azure board, or you know, some ITSM tool. So do you have something that can give a result? Based on that, you can say whether it is ready for deployment. I mean, it is ready for uh, promotion to the another environment or not. So all those things you need to evaluate with your team, that what are the things we can do the automation, who are the stakeholders who must be there before it goes to prod. Now this is example of continuous delivery, as we have discussed on the previous slides. Because you are putting manual approvals, then it is continuous delivery. It is not continuous deployment. But what happens is that based on the learnings you have here, you know, over 6 months of time, over over number of releases that you are doing, you might learn that okay, every time it is going to QA to prod, the developer is missing this DB connection string. Example, just an example. He might be missing a JSON file or a config file. I mean, these are all learnings you got over period of time, over 6 months, over um, over number of releases, 6 releases, 7 releases. These are the, and then based on these learnings, you start incorporating these during previous cycles, maybe during the CI pipeline or maybe in the CD pipeline itself, so that these things will not happen next time. So slowly the issues that are getting reported during the manual approval process are getting reduced. So when you started, it it started with 10 number of issues that are getting highlighted by these approvers, that okay, there are 10 issues that needs to be resolved before it goes to the next the production. And then slowly over 6 months, 1 year, 2 year, 3 years of time, you learn that now we are not getting any issues. It is just like a manual approval only, a kind of a bureaucratic process only. Now there are no issues as such. There is no, I mean, all the issues that were happening, we have been able to cover them during our CI pipeline and CD pipeline itself, whatsoever it may be. Then what you can do is you progressively, the organization remove this manual approval, because they see that okay, over last 10 releases, we have never seen any issues during the manual approval process. And then they say that, okay, now we have improved our delivery process and now we are continuous deployment. And that's how the organization matures from continuous delivery to continuous deployment over period of time. It's not a one-day job. It's not an overnight job. It's a continuous process. And that comes as a feedback. If you put things over here, if the review is properly happening, if people are looking at the things from the perspective that needs to be removed in the future, and that's how this manual process will be removed. And then what will happen if you have this continuous deployment after 6 months, 1 year, whatever years it may take. For some organizations it may take 6 months or 8 months only, but for large complex environment it may take years. It may take 5 years, 6 years. No issues, no problem. It will take, because it's a complex application. There are n number of permutation and combination that needs to be validated before it goes to prod. And that's not a big issue. It should be there, because you need to make sure when you are releasing the software it is bug free, at least uh at least I mean there should be minimum bugs that should be going into the production. So when you are following this pattern, you will be able to mature your organization over period, and then when you mature, then you call it like continuous release, continuous deployment, and this is a continuous improvement process that does happen over period. It is not a one day job or one night job where you just put things in the pipeline, you create a package, you create a definition, you create a script, and then you can do the CI and CD pipeline automatically. It is not like that. It will take some time to understand the philosophy and to implement the practices in the culture, and then after few years when you are in the continuous deployment mode, you can be rest assured that whenever the changes are happening, it is continuously deployed, midnight, overnight, whenever there is a problem, whenever there is a security bug or any patch that needs to be implemented, you don't really have to worry about your infrastructure team dependencies. You don't really have to worry about your security team dependencies, because all those things are already automated. There is no manual process that needs to be validated as long as things are covered. Now, the next section we have is plan the deployment environment strategy. So how do you plan your deployment? What are the various release strategy you have? So when you deploy resources on production, so you have your production and there is already a version 1 running, version 1.0, and now you are, your CI pipeline has generated and all the things are there. Now you are running, you supposed to deliver 1.2 or whatever the version it is, the next version. Actually it should be 1.1 because previous one is 1.0. So suppose you have 1.1 and that needs to be deployed. In many of the products, it is not possible to deploy directly. When you deploy directly, and suppose some users are connected over here, that it may be a problem for users. Some features of 1.0 is not available while they are using it because 1.0 1.1 is getting deployed. In such scenarios, you need to plan the deployment on this target. One of the release strategy that we follow is blue-green. Blue-green deployment pattern, what it says is that it considers, so it considers one environment as blue, that is version 1.1, and one environment as green, that is version 1.0. Now what happens is that it it maintains, sorry, it deploys this next version into this blue environment, and slowly users are being redirected to this environment. This way, this slowly this will become obsolete. No users are connected here, and then once it is obsolete, then it will be removed, and then new users will always connect to this particular environment. This is kind of a you maintain two copies. One copy has a one version and one has 1.1 version. You just maintain where users must be connected, and that is how you implement this blue green deployment when you have a next version. Similar to that, the another another this thing release strategy is canary. In canary deployment, what you do is let me clean this up. So in canary deployment, what you do is uh, you you deploy 1.1, 1.0 is already there, 1.1 you deploy, then you select certain users. You select certain users and will be using this. These certain users might be you select these users based on their interest in the application, or there are certain section of users who are already always uh, you know very excited about new features and all. So you select those users based on some survey or based on some analytics you have, uh, based on the use cases, and then you are provide them this new 1.1 feature, and 1.0 is already available to large chunk of users. And then you kind of expand this user base slowly. Whenever you see that, okay, there are for few more users who are available, who can test these users, and then when you are confident enough that, okay, features are working fine, based on these users feedback, you are implementing the bug fixes and all, and then once you are confident enough, then you just replace this 1.0 to 1.1, and then this 1.0 goes back, go away. Similar to this is ring, which is also like canary, but the only difference here is that suppose you have this user base, you select a certain users, you know and they are provided 1.1, and slowly you expand this particular ring. Now suppose the earlier this were 10 users, now this is 15, and down next 20. Now in the next ring it will be 25, and slowly it will cover all the users. And that's how you start expanding your ring for users. There are various tools and technologies which are available to implement any all of these deployment pattern. In the next slide we will be talking about that, how do you implement these things. But these are the three major release strategies which are used based on the company, based on the organization, based on the product that you're using. How do you implement these? One of the option that you have in Azure Web App is deployment slots. So in Azure Web App, if you talk about Azure Web App, you have something called slots. What do you mean by slot is that you can create a slot like by default prod slot is already there. When you create a QA slot, it gives you replica of your web app. It is complete replica with configuration and everything. It is like my site dot Azure website .net, and then there will be another thing which will be QA my site. So it will be a separate instance of my website having a separate deployment target and everything. So you in one single web app you get two copies. One is prod slot, another is one is QA slot. It is a it is a web app feature. And if you want to make use of this feature, you can create the slot, and once you create the slot, you target your next version 1.1 on this slot. Now you define whether user should be going here, so that you give the URL to them, that QA slash my website, whatever you can say, or by default they are going to the prod, which is my site dot Azure website .net. So by default they are going there. For selected few you are saying that, okay, you can go there QA dash my site dot Azure website .net. That way you will be able to access 1.1 version instead of regular 1.0 version. And this way you can implement deployment slots. So this is your blue environment and this is your green environment. And then there is a way to swap the slot. So what does happen that suppose you are confident enough that 1.1 is ready to take the load of all the users, based on the features and based on the bug fixes and everything. I mean, you are confident enough that now it is time to deploy it to the production. There is an option to swap. So you swap the slot. So what does happen? Whatever is there in production, it will come to the QA, and whatever is in QA, it will go to the prod. So now prod will have 1.1 and QA will have 1.0. Why? Because I mean this 1.1 is there so that users will be able to use the latest one because you have swapped the slot. But just in case you want the previous one again, then you do the another swap and then you have the previous version. Then again 1.1 will come to here and 1.0 from here go to there. So that way it also offers you the restoration type of feature where you can restore your previous version, just not upgrade your version. It also helps you to restore, the environment blue to green, green to blue. Both sides are applicable. You can do the both side swap. So you are ready with the you are ready with the 1.0. 1.0 was the old one. You were ready with 1.1. You did one swap. 1.1 is available now. Now later on you figured out that your management is saying no, we need the previous version now because new version is not user friendly. A lot of users are complaining and all, whatever. You just do one more swap and your old version will be available in your main website. And that is how swap, slot and slot in Azure App help you to implement this blue green deployment. Similarly, you can make use of load balancers. So, suppose you have an environment, this one, you have another environment, one is having 1.0, 1.1 is having 1.1. You put a load balancer in front of it. You, based on the load balancer rules, you forward the people to one version and another version. Similarly, load balancer, you have traffic manager. You can make use of traffic manager's rules as well to send certain traffic to one place, send certain traffic to another place based on the rules that you want to define. Again, that rules may be based on the blue green, based on the the ring, or based on the canary. Whatever you want to want to implement, you can implement either of them using these features which are or tools or services available in Azure. Feature toggle is another tool that is available. We have discussed about it in our previous session. Feature toggle enables you to to enable certain features based on some configuration changes. So normally in all other deployments, like here is 1.1 and here is 1.0, you actually running two versions of your application in any of them, blue green or deploy, canary or whatever. If you follow any of these implementation tool, you are actually running two targets where one of them is running 1.1 and one of them is running 1.0. But it is also possible that you upgrade your 1.1. Your target is one only. The servers are, you don't have multiple servers. You don't have one server only. But here in the server itself, you have some configurations. Suppose you have like feature one F1, which is on for certain user, U1, U2. That's it. And there is a feature two which is off for certain user 3, user 4 or whatever. So as and when you want to change this, change this configuration, normally it is like config file, some XML file or some JSON file. You just change this configuration. You don't really have to do the deployment. Just change this configuration, and there are ways to do this. Then application will automatically be able to pick it, and then it will be able to apply those changes for certain users or certain groups. This kind of implementation is done by Microsoft as well. If you heard of, there are certain things like private preview, public preview, where Microsoft says that you want to select a particular feature, please go ahead and either raise a request or go ahead and change this particular configuration in your subscription setting or in your profile. You just change that particular setting in your profile, you will be able to access that particular feature, which is part of the experimental feature, sometime preview feature. So the where feature is already available in your application, it's just that configuration needs to be changed. The moment you change the configuration, the feature become available for you. Microsoft is not going to do a next deployment. It is part of the same version itself. So feature toggle can be useful in such scenario where you want to allow certain features available to certain people selectively. Either you select them or they can select themselves. Certain features where Microsoft will not allow you to select, they will ask you to send them email and they will change those settings from their end. They must be having some configuration on their side portal, and certain features they will allow you to opt. Like there is an option where you go and select the preview option enabled, and then you will be able to see those things in those services. For example, in Azure DevOps as well, there is an option where you can select the preview features, and then those preview features will be available for your profile or for your organization. Now the next thing is desired state configuration. Now when you deploy certain things in server, so suppose uh, you had this version 1.0 of your application and your infra is also 1.0, and this is your whole server. This server does have the application, certain files, exe, espx file, java file, whatever it may be. And then it has certain features in terms of infrastructure, like it has some .NET framework installed, some version is there 4.5.1. It has some other tools, like some other framework, like some other tools which are required to run this application on this server. Maybe um, some dependency files, some package files, and some features like Windows features, some Windows settings in terms of registry, in terms of application, in terms of file system. Those are there, which are configured as part of infrastructure. And again, all these things you have done, the complete infrastructure definition you have done with ARM template or Terraform, that is up to you. And then application, of course, it is coming from the code. Now, what happens is that over period of time, application code normally do not change by itself. Of course, it is not going to change because application code is automatically coming from here. And until unless someone goes there and do the changes, it might not get changed. But in infrastructure, you cannot guarantee that actually. What happens is that this .NET framework itself, it may get upgraded. Some update may come, and that update may update it like 4.5.2 or 4.7 or 5.0 or whatever. This number can get changed. Some of the Windows setting that you have configured for this application to be working, that setting might have updated because of some Windows update. Some Windows update from Microsoft, or some from one of the application team, or someone came and you were not aware, and those changes changed your Windows setting in a way that can affect your application working. This is what we call server drift. Server configurations are changing. Now in such cases, what happens is that it becomes difficult for infrastructure engineers to evaluate what those root cause were. Was this Windows update? Was this what? Why this particular thing changed, and how to correct it. In such cases, what we do is, just like we have this Terraform, we use some technologies, like they call it desired state configuration. This is a philosophy which says that instead of installing .NET framework, why don't we have a script which says I need .NET framework, .NET framework 4.5.1, and I will just tell this to this server, and then from where it needs to be installed, it will automatically install it, and it will always keep checking that whether this particular framework is available or not. As and when this is changed because of some manual change, because of some Windows update, because of anything, it will, this script, the this validator, we call it desired state, will keep on evaluating. Oh, okay, there is some change in 4.5.1. It is not available anymore. Let's go ahead and install it again. So it will install automatically. So it will keep checking those configuration. So it will keep checking these configuration and will make sure that if at all, because of some changes, if these things are getting updated or getting changed, if at all this .NET framework is updated, if at all this file is getting deleted or moved or whatever, if at all this registry key is not valid anymore, this desired state DSC, desired state configuration, will make sure that it gets implemented automatically. So it's kind of a governance, it's kind of a policy, or it's kind of a something which keeps on checking if things are working as expected or not. And if they are not, then it will make sure that those things are as defined here. And if things are not able to update as defined here, it will report you the error that okay, initially you said to me that okay, desired state is there has to be C drive test file test.txt. Now this test.txt is not anymore there, and I am not able to create it, because of any reason, because of some file permission changes, or because of someone has done something or whatever. So it will also report the error, and then based on that error you can actually go back and see whether you want to do the complete infrastructure deployment again, so that this can be corrected, or whatsoever action item you need to take. But desired state configuration will make sure that your infrastructure is always in desired state. That's what it means. Your infrastructure will be always in desired state. What is the desired state? You design it or you define it using a configuration file. Now there are various technologies to implement this DSC. There are various technology. One of them is PowerShell DSC. So PowerShell itself has a DSC configuration format using which you can create a DSC file, which is desired state configuration file, which is called configuration file. And based on this configuration file, there is a way to implement this on the server or on the application on the server or on the virtual machine. And if at all that virtual machine is changing its state from the desired state configuration, then this PowerShell DSC will make sure that DSC is maintained. In terms of application installed, in terms of registry, in terms of file system, in terms of whatsoever. There are various resources available. We call it resources. So file on a server is known as resource. Registry on a server is known as resource. In Windows feature is known as a resource. Now based on these things, PowerShell DSC will make sure that whatever you are defining in your DSC file, this is PowerShell DSC, whatever you are defining, these will keep on they will get on implemented on the server. And if at all something is different than this DSC configuration, it gets implemented there. This is what the work of PowerShell DSC, and that is how you can enforce certain properties, certain configuration in particular way, in a desired way on your server. Now apart from PowerShell DSC, which is part of PowerShell, but it has a little bit different format than regular PowerShell script. You can go there, you can see what is the exact format. PowerShell DSC is also available in Azure Automation account. So you can use Azure Automation account to implement PowerShell DSC on Azure virtual machines. But you can use PowerShell DSC to maintain your on-prem virtual machines or on-prem Windows server or Linux servers as well. Now similarly, you have Chef. It's a third-party tool that also works on desired state configuration philosophy, where you have Chef files. Using those files, you can actually define the desired state of your server, and then that particular state will be maintained. There are other PowerShell DSC works in a on a different format. Chef works on a different format. Similarly, you have another tool called Puppet as well, which can also help you to implement PowerShell DSC. Desired state configuration DSC. PowerShell DSC is a complete name of our technology, which is coming from PowerShell itself, but it is a different format, different way than regular PowerShell. Similarly, the same philosophy are deploy or are implemented using these two different tools like Chef and Puppet. And there are other tools as well. We have just named some of the few popular one, and which are also mentioned in these exam exam curriculum. Now when you implement this a new server, a new version on your system, on the server, you have to also maintain the downtime as well. Now what do you mean by downtime? uh, of course, when you put version 1.1 is 0, 1.0 is there, 1.1 you are putting, you have to maintain that when 1.1 is going there, it does not implement any existing users, it is not causing any downtime or something. Again here swap slot, slot in the uh, Azure web app can help you doing that. It has it has no downtime actually, because the moment you do the swap, it automatically puts the other version in the slot, and then it is available for all the users. Similarly, you have load balancers to manage the balancing. Where few users may go here, and based on the few user may go here, and then on the load balancer level, you can define uh, when do you want to kind of drain the connections to previous version, all right, and send all the connections to this new version in terms of any other version change. And the rolling update is another option which is there with many platforms like Kubernetes and other platforms as well, where what you do is you suppose you have 3 instances, skill set or something like that. You can think of it like all of them are using app v1, app v1, app v1. Now and then let's do one thing. This is 1 instance, 2 instance, 3 instance. This is app v1. This is also app v1, and this is also app v1. Both all of them are load balanced using any one of the technology like load balancer or traffic manager, whatever it may be, and sending traffic to there. Now you thought of, you have a new version v2. Now what you do is you plan to update this one, keep these two as the v1 only, and you just break this connection from here. All right, actually do this way. You break this connection and you update this guy from v1 to v2. All right, and then certain number of users, you define the rule, you change the rule in a way that 20% of the user may go to this v2, and then slowly you once this one is updated, once this is v2, then you do the same thing here, v1 to v2, and then next 30% or 50% goes here. And similarly, you in the last you do the changes over here as v2 to v1 to v2, and then rest of them are going here. And that way you are kind of balancing the rules that what are the people are getting the latest update. At the same time, you are rolling the update. You are rolling, you are changing update on one instance, then the another instance, then the another instance, and that's why it is called as rolling updates. So we have just given you the example of this virtual machine. Similarly, similar kind of thing can be done with other platforms. Many platforms supports this particular feature, including Kubernetes. Kubernetes has a inbuilt feature which can help you to do the rolling update. I suggest you to go, just find out Kubernetes rolling update, and you will be able to find the documentation which will tell you how do you implement this particular release strategy, so that you can get the minimum downtime for your applications changes. So this is the way you can implement or you can plan your release strategy in your infrastructure along with the application changes. Now we have a 10 minutes break. After 10-minute break, Sanjeev will be uh, going through the demo. This is the demo that we have planned. the demo that we have planned here is to automate the infrastructure using Terraform and Azure Pipeline, where we will be exploring Azure Pipeline. At the same time, we will be looking into the Terraform uh, basics. It is more or less oriented towards how the Terraform looks like. How do you build your application infrastructure, you're using Azure pipelines, and how do you deploy your infrastructure using Terraform in Azure pipelines. So we will be going through all these steps in the Azure pipelines. uh, Sanjeev will be taking us through this demo after 10 minutes. So let's have a quick 10 minutes break, and then we will come back with this demonstration. After demonstration, we will have a quiz. The quiz will be we will be having this quiz for selected few. We will be having free exam vouchers. So if you participate in the quiz, and if you have also registered on our Eventbrite page, then we will be selecting few from the list of all the participant of the quiz, and then we will be selecting few in the next session for winner of quiz for the free exam voucher. Also, we will be having the the winner of the previous session. So whosoever has joined us in the previous session, we will be selecting few online today itself, and we'll be showing the names whoever are getting selected randomly. They will be getting the exam free vouchers from us for the previous session. So we'll be announcing the winners, as well as we will be opening the quiz for the next session in after the demonstration. So let's wait for next 10 minutes and then come back, and then let's join us for the demonstration as well as quiz. Thank you. All right. Sanjeev, you there?
Yeah,
Please go ahead and share your screen.
thank you, Asis, for giving me this opportunity to give in a lab on Terraform. And thank you also for demonstrating all the ideas for the CI/CD pipeline and the deployment slots and everything. So here I will be demonstrating how to use Terraform to manage your infrastructure. So is before moving ahead to directly integrating Terraform with a CI/CD pipeline, I will be briefing about normally how a Terraform scripts or Terraform configuration looks like. So if you see, let's move ahead, and this is my Azure resource group. And if you see, I don't have any resource group create, only one resource group created over here. We'll go ahead and create a simple Terraform from the cloud cell provided by the Azure itself. We don't need to be, you can do it from the locally installed PowerShell modules also, but we can do it from here as well because it's already, Terraform is already integrated over here. So if you go here and if you see the Open Editor tab over here, and if you click on this, we can create a simple Terraform configuration to create a resource group inside our Azure. So I will for that I will be writing a script for that. So I'll writing a Terraform script and we'll save that Terraform file with .tf extension. Then we'll do some manipulation to run the Terraform script. So normally Terraform goes in either 3 or you can say 4 stages. One is init, one is plan, and one is apply, and another one is destroy. So normally, mostly we go from init, plan, apply, and at the later on, if we want to destroy the resources, then we can go ahead with the Terraform destroy command. So first of all, we need to create a Terraform config file or script file, I can say. So for that, I will be creating a Terraform file over here. So for that, I will be writing the provider. So if you go over here and you type Terraform, then you will get a lot of help from all the commands available for the Terraform commands available in the Azure or PowerShell module. So the main commands, as I said, the init, plan, apply, and destroy. And others are like we will be using the providers who will be the providers, like in our case it will be Azure RM. So let's go and create the Terraform file. Here I will be writing the provider will be Azure RM, and we will be writing what is the version. So if you don't know exact version of the Terraform, then you can just mention if you want to point to any 2.0 version of the Terraform, then you can directly write this one. So and another thing is, after the 2.0, the feature tag is mandatory in the Terraform. So recently, when I was upgrading a Terraform to this one, I got to know that. So if you go ahead to the normal 1 version, then you don't need the features tag. But from the 2.0 version, they have made it mandatory. So keep in mind, keep on mind that. So I'll go ahead and then I'll type the resource Azure rm underscore source underscore root. Let's name it as
The syntax that Sanjeev is typing here, all these syntax will be available in the Terraform documentation. The idea over here we are trying to demonstrate is that you can create a Terraform file in Azure interface itself. That is the Cloud Shell that Sanjeev has opened. So this is Cloud Shell. In the Cloud Shell, there are a couple of tools which come as pre-installed. Ansible and Terraform is one of them. So Ansible we are not demonstrating, but Terraform we are demonstrating. And the editor that Sanjeev is using is similar to Visual Studio Code. So you can actually do a lot of Terraform coding without having to have all those tools on your laptop. You can directly do it in the Cloud Shell, which is freely available, and you can almost freely available. There is a little bit of cost involved, but very small cost is there, and you can do all these things there in the tooling point of view. That is what we are trying to demonstrate. Okay.
So you can copy the Terraform tags, and I didn't go and search and copy it, so I know, so I'm just typing it out. So you can go ahead and save it. Let's say it's a demo 16 December. Let's save it as the Terraform file needs to be saved as .tf extension. So I'm going ahead and saving it. So let's check. So we have our demo.tf. So the folder inside which you are putting the Terraform commands, in that folder the TF extension file should be there. So let's go ahead and do Terraform. As I mentioned, the flow is like it's from the init phase to the plan phase to the apply phase. So let's go ahead and do Terraform init. See, and let's go ahead and we'll see Terraform plan. So then let's go ahead and do Terraform apply. Our resource group gets created. To put a value yes.
Sometime it takes time. Just refresh the complete page itself, the browser page. I mean browser.
If you see this resource group got created. So now let's go ahead and destroy this the resource which we added. You can do that by Terraform destroy.
Sanjeev, can you minimize this MS Team window?
So destroying it will take some time. So it's got destroyed. Let's see. And if to refresh over here. Yeah, that's fine. So this is the basic Terraform configuration and the phases which we can use it to.
Sanjeev, can you please unmute yourself? By mistake, you got muted.
I think now you can hear me.
Yes, it's fine.
Yeah. So as you can see with the Terraform destroy, the resource group got deleted. So I think this is the basic things which I covered just in the Terraform, how you can write the Terraform configuration file and how you can use the init, plan, apply and destroy command to phase out your Terraform configurations to manage your resources. I think Ashish covered a lot of areas on that. I'm not covering the theory part of it. I'll be directly going ahead and putting that Terraform to a normal, I can say .NET Core or .NET web application, where I will be deploying the .NET web application with creating a app service plan and creating deploying the .NET app into the app service. And we can see it, the .NET application will be hosted in the Azure App Service Plan, and we can browse that application. So this is a simple .NET application which I have created, and this is the simple Terraform app which I have used. So I'll be covering all these parts, like what it does, what it from where it gets the data and all these things. So as you see, like I have used the same provider Azure RM tag over here. Then I have just created a resource group called Simple Web App. You can get this value from the pipeline also, that I will discuss when I'll show you the pipeline. And this is the app service plan which I have written to create the app service plan. And then it is the app service which I'm going to deploy my web application over there. So let's go ahead and see the pipeline and release pipeline. So let's go ahead. This is my simple web app. It doesn't contain anything, only a simple .NET application. It's the template-based application I have taken from the Visual Studio, nothing else. So if you go ahead and I have checked in the code over here. So this is the structure of my Terraform application. So here is my solution file and here is the project file. And in here I have created a Terraform folder, and this is my Terraform configuration file, which ends with a .tf extension, as I mentioned earlier. So if you go ahead to the pipeline, I have created a pipeline called Terraform Web App -ci. Let's consider it as a Terraform Web App continuous integration pipeline. So if you go ahead and I'll show you what are the tasks I have in the pipeline. So in this pipeline, if you see, I just restore the .NET Core library over here from the NuGet package. Then I do the build. Then I just do the publish. All these things you can just whenever you create a pipeline, you just type it here. You can add the task over here, like the build, test, package. Yeah, this one you can choose what you want, the restore one, whether the publish one, whether the build one. So from here only I have added these tasks. So whenever you are creating a pipeline, you can just do this. I have added the restore, then build, then the publish, And then I have added the copy file. I just wanted to copy the Terraform file because the Terraform file we need into the continuous delivery integration. Otherwise, I cannot include. I need to include my Terraform file so that during the continuous delivery we can use that file. So that's why I have just added the copy files task. You can do search for the copy files from here, and you can add the source and destination. I have just done that. Then I have done a publish build artifact, which is also you can just search it here.
Yeah, and that's how here Sanjeev is what he's trying to demonstrate over here is that his application code and his Terraform, which is infrastructure as code. So infrastructure and the application both are defined using code. Of course, application has been defined using code only, but now we are defining infrastructure using code only, and then we are using the concept that we have discussed during theory, that is, couple application and infrastructure, right? I mean, we are coupling them together. Both are being managed in the infrastructure, in the version control, and then we are designing the pipeline in a way that we can get the information from infrastructure as well, just like he had put it things in the folder. Now infrastructure teams can work in that particular folder, in the Terraform folder, and the application team can continue working on the solution file level, on the .NET level. And then pipeline is actually trying to take both the things, and then Sanjeev will demonstrate that how these two things are, combined together to release into a Azure environment, using code and infrastructure together. Yeah, Sanjeev, please go ahead.
So this is specific to .NET Core application. I'm talking about the build, publish, all this thing I have written. The copy files is a normal one. So let's say you are going ahead with a Python or Java application. There might be some different tasks I'm not aware about, but you need to just I think there is PyPy publisher, but I'm not sure. I have never done that, but I'm just talking about a .NET Core application point of view, but it will be similar to all the applications which you will be using in your day-to-day life. So you can go ahead and create search for the task, and you can add it. So this is my my pipeline YAML file, which I just showed you. I have not much on this, so it's a simple task I have just added. And I have added a variable over here, which is called build configuration, because in .NET you can build the whether you want a release build or whether you want a debug build, because normally the debug builds will be having the PDV files, which are called the debugging files. So you don't need those in a continuous integration. Means in an artifact you don't need those data. So I have mentioned the build configuration, which you can control from the variable group, so that if you go to the build here, I have just added the build configuration as release, and the build platform, either you can build it as a 64-bit platform or a 86 build platform. So that's based on your application, which type of platform you want to build, but I have built it as any CPU platform. So this is my the CI pipeline YAML file. You can it's a simple one, so you can just go ahead and add the task whatever you want. So I will run the pipeline, and started creating a artifact, and my artifact number will be this one. So let's go ahead and run it. Okay, so while it is taking time, I'll go ahead and show you the release pipeline, which the continuous delivery pipeline which I have created. So if we go ahead, this is my continuous delivery pipeline. So here you need to add the artifact which you want to. So from the CI build where the release gets generated, from that you can, so whenever you create a release, so release pipeline, you need to give the artifacts from where you want to get the package or the artifacts, the source of the artifacts. So that's what I have just created over here. Then we'll go ahead and see I'll explain I have added some tasks or the job into my continuous delivery pipeline. So here my first pipeline in the job or task on my pipeline is deploying the required Azure resources, where I'm creating Azure resources where my so normally whenever we create it, when we create a Terraform or when we apply the Terraform file, it maintains a state inside the resource group storage account. So we call you can call it as the path will be like a resource group. Inside that there will be a storage account. Inside that there will be our Terraform container. Inside that it maintains its state. So that's why we need the minimum resources to be created where my Terraform will be maintaining its state. So that's why I have added a CLI, Azure CLI task. So if you want, I'll show you. So whenever you want to add any task over here in the release pipeline, you just go ahead and add a task, and I'll show you how I have added the Azure CLI. So you go ahead and type Azure CLI and you add it whatever you want to. What is the subscription and what is the script you want to run. So here I have added to create a resource group and a storage account inside my resource group. So this is the script I have added inside as an inline script to perform to create the resources for my Terraform maintaining its state. Then next is I have added a task called Azure PowerShell script. In this, I'll be getting the storage account name or the storage account key, which I will be using in my Terraform. So this is the script I have added. These things can be is available in the if you are not able to write the PowerShell script and all, these are available on the internet. You can get it or it's in the Microsoft website also. So then I have added a token replacement replace token task. So that is because if you go ahead and see, I have added some variables over here. I don't want to hard code my app service plan name or app service name. So that I wanted to get it from the pipeline itself. So because the developer should not have access to what they are writing over in the Terraform resource name, the developer should not have access. So that's why I have, if you go ahead and if you'll see, I have created the variables called app service name and app service plan, and from here I will be picking it up. So if you go ahead and see the replace token, I am saying that. So I am saying that this token prefix and token suffix. So this replace token is used for these variables to be replaced with the replacing the variables. So then I have my install Terraform job, which is directly you can just go ahead and ask for the install Terraform. So you add it and rename the display name, whatever you want to install Terraform with the version number or something like that. You can do that. Then my Terraform init is there. So I have added the Terraform init from the task itself, you can go ahead, you can do this Terraform execute. It has all. So whenever you add the Terraform execute, it has the command like what command you want, like the init or the plan or the validate or the destroy or the init, validate and apply. So you have these options. So you add that job, and you accordingly you select the command. And here I am mentioning from where it will be, what will be the source Terraform file, where you will be mentioning the Terraform configurations. As Ashish mentioned, we'll be integrating the Terraform with the normal developer code also. So if I go to my pipeline, if you see, so I go to my artifacts inside the drop. If you remember in the pipeline, I have mentioned that the copy the Terraform file. So here I have copied the Terraform file. So this is my artifact looks like. So this will be provided to the Terraform engine to run the script so that it can manage the resources. So let's go ahead to the release. Okay. So inside this is the configuration directory from where you want to pick the Terraform. Exactly speaking, where your Terraform configuration files are. So you can go ahead and browse it, or if you know the exact location, you can directly put it over here. So it's and here I am mentioning that what is the Terraform resource group where this Terraform will be getting executed on which resource group. So this is the resource group, and this is the storage account, and this is my container name. And this normally the Terraform maintains its state in a .tf state file. So this is the name I have given. So then it's normal one, as I showed you in the initial stages, where I added the init, plan and apply. So this is my this is the same task which I told you is Terraform. You can you select it and select the command as plan. So then you also need to specify the directory from where it will be picking up the Terraform file. Then your Terraform apply. So remember, if you are Terraform, you want your resources to be managed without any approval. You give the command as auto approve. Otherwise, it won't work. So you need to give this additional command as an argument so that it can manages your resource without anyone's approval. So then I have my Azure App Service Deploy. This is also a task which is available. It's a simple task. You go ahead and for Azure App Service. I think Azure supports a lot of technologies to be can be deployed into their Azure App Service, where you can manage, you can host your application. So this is the task which I have selected, and if you go ahead and you just tell the app service name which I have created in the variables. And I'm saying that from where, if you see my pipelines, I'll show you in my pipeline, I have a zip folder where my artifacts is already published. So I want the package folder to be deployed into my Azure App Service. So this is the stages, basic stages of an integrating the Terraform with your application to manage your resources inside your Azure. So we'll go ahead and see.
Sanjeev, just here on this screen, can you please go ahead to the CD definition? All right. So as Sanjeev has explained each one of these tasks, if you look at this task, we are doing three things. Okay. One thing, the very first few tasks are creating some environment in Azure or some file system. So if you see, he is creating some resource group, then he is tokenizing some information like variables, and he's replacing those variables names and all those things. So it is kind of creating the environment which is required for your application or for your infrastructure, which may change based on your application, based on your platform, based on your services that you are using. So as Sanjeev has said, if you are working on some Python application, the task may look different, the type of task you may require will be different, and you can go ahead and search tasks there appropriate to your environment, appropriate to your need, whatever you need, so to prepare the environment. Now the next task Sanjeev is doing is he's working with Terraform. So, he's doing the Terraform installation on the agent server, then he's doing the init, then he's doing the plan, then he's doing the the apply, the same thing which he demonstrated on the Azure in a manual way, where he created a file manually, he deployed it using the manual way. The same thing he's incorporating in a pipeline using some task that can be run automatically in a pipeline. So there he was doing in the cloud shell, here it is happening in the pipeline itself. And the last thing, which is Azure App Service Deploy, it is actually the application deployment. So first you create the environment specific configurations, like some files, some tokenizations and everything. Then you create your infrastructure using the Terraform files. And the third thing, which is your deployment of your application. So these three things, if you see on the release strategy, this is what we are doing. I mean, this is what we have discussed. Configuration as code, infrastructure as code, configuration as code, the first thing. Second thing, infrastructure as code, that is Terraform. And the third thing is, application, which is already there in this, which is already there in the application form, in the code form, and you just have to deploy it. And that is how you can apply these principles to design your strategy. This is a very simple strategy we are demonstrating just to explain you the the concept, the features which are available. But the same kind of basic principle can be applied to any complex architecture, any complex infrastructure, and you can, then you can take it further and then explore the Terraform, explore Azure, infrastructure, and based on your complex requirement, you can design your release pipeline accordingly. This is a building block that we are talking about. Yeah, Sanjeev, thanks. This is it. Thank you.
So as Ashish mentioned, so the major building blocks of Terraform is these three: the init, plan, and apply. And another one is whatever configuration codes you are writing over here. That depends on your requirement. So here I needed a app service plan and app service, so that's why I have used that. So and the resource group where I will be deploying my app service plan and app service. So my Terraform state will be maintained in a different resource group. As I mentioned, this where I will be, my Terraform will be maintained in a different resource group. Terraform state will be maintained in a different resource group, and my application will be maintained in a different resource group. I didn't want to be. You can do that in a single resource group also, but I did it in a different resource group. That's up to your requirement. So let's go ahead and check if my pipeline already. Yeah. So if you see my pipeline is already run. So let's go ahead and create a release. So if you see here, I have just created a dev release. You can move ahead. If your dev succeeds, then you can go ahead and deploy to the QA. That's your strategy. I think Ashish went ahead with mentioned some of the strategy from the dev to the QA to the production. Or if you want to introduce any other system, you can add different stages of your releases. So I have created a dev release. So let's go ahead and create a release. Let's see. So when you create a release, you use that which, as I am doing it as for the dev. So I have selected it dev. Here you can select the which version of your artifacts you want to use. You have two artifacts. You can use the second version or first version. So I'm going ahead and I'm applying the version of my artifacts. So let's see. Go ahead and deploy it. Let me check. Yeah.
We have already discussed details of this, Azure pipelines, how these agents work and all in our previous sessions. So if you have not attended, then you can watch our YouTube channel. There we have uploaded all the sessions, the previous sessions, where we have discussed the details of this pipeline, where we are discussing how these agents works, what are the various options you have, how these, what are the various options means on this screen. uh, the detailed we had a discussion about continuous integration and Azure pipelines. Okay, so it's running. It will take some time to create the infrastructure as well as to deploy the application to the infrastructure.
As Ashish mentioned in the previous class, we covered all those areas in the Azure pipeline. So it's easy. You don't need to write the YAML files by your own. You just add the task or add the task. The YAML file will be created by its own. So for the simplicity, you can do that. Or if you want a complex one, once you do the building blocks on that, you can go ahead and do on top of that. But it's easy, I can say. So our release succeeded. So let's go ahead and check. So as I mentioned, this CD pipeline creates two resource groups. One is for the maintaining the Terraform state. So here is the, if you see, this resource group, this resource group has a storage account which maintains the Terraform state, and this is my application resource group where I have deployed my sample app. If you go ahead and this is deployed, and if you go ahead and browse it, my application would be up and running. Let's see if it's, yeah. This is the normal, as I mentioned, it's a simple .NET application and it doesn't have anything. So this is deployed and this is running. So that's the end-to-end Terraform implementation in your, I can say, continuous delivery mechanism. If you have any question, you can put it on the Q&A section, and I think Ashish can take over it from here.
Yep, thanks, Sajeev. Okay, so what we are going to do now is we are going to open the quiz, and we have let's just give us a moment. Let me open the quiz, and And let me share my screen. Okay. So the quiz is active now on this URL. This URL you can access. This will be soon putting it on the chat as well, and then you can answer your answers. Put your answers there. We request you to take 10 minutes. I mean, it is active for 10 minutes only. So you will be able to answer this quiz for 10 minutes only. After that, we will be deactivating the link. So quiz URL is available in the chat section as well in the Q&A. Once you are done with your quiz within 10 minutes, if you have any question, you can also post it there. We will try to answer your quiz, your questions, and if at all we are not able to due to time constraint, we request you to join our DevOps group and then post your questions there, and we definitely will try to answer your queries there as well. So let's. So it's 9. We will be. So it will be active for 10 minutes. After 10 minutes, we will be opening, we will be announcing the winner of the previous session quiz. The winners will be getting the Azure exam vouchers. For today's quiz, we will be announcing the winners on the next session, which will be on 6th February. We request you to put your email ID and your organization name there. We using email ID, we will be connecting with you to provide the voucher if you will be selected the winner in the next session. And also the organization details we need to have so that we can share the details with Microsoft, and probably they can work with. I mean, they need to track how many people are getting certified, and probably they will be able to understand the trend, how many organizations are making, getting benefited by these benefits that we are getting from Microsoft. So Microsoft is allowing us or giving us these vouchers to distribute, and Microsoft wants to understand how these vouchers are getting used by various organizations and how organizations are helping you to take the certification. So it is definitely going to help you to highlight your achievement.
So 5 more minutes for quiz, and post that this quiz link will be disabled. I can see a lot of people are appearing for the quiz. And Ashish, I really appreciate that even though you are not well today and you delivered the session.
No issues. Thank you.
So 2 more minutes. Post that this quiz link will be disabled. So thank you everyone, all those people who have appeared for this quiz, and all the very best. And I wish that most of the people who appear for the correct answers, they should get the exam voucher, and that should be announced in the next session. And for previous sessions, Ashish, you can go ahead and announce the winner for the previous sessions. Quiz link is disabled for today's sessions now.
Yeah, sure. Let me share the screen again. Let me share this quiz. Okay. So what we are going to do is we are going to put the names of the users here who participated in previous quiz. So all the names over here. In total, we have 33 entries after removing the duplicate entries as well as those people who registered registered for our session. So just give me okay, so whosoever has registered for our session and also participated in the quiz. So we have all the people here. So just want to make sure, just want to highlight this aspect that you should be registered on our Eventbrite page as well as provide the correct email address in the quiz. Then only you will be able to get the name over here. Now what we will do, we will just run this wheel. It will randomly select one name from the list, and then it will that name we will be selecting as a winner. We'll be selecting 6 people, 6 winners for this session, and similarly for this session we will be selecting 6 winners in the next session. These winners are getting selected from the previous session list. Okay, so I'm just running this wheel after getting the name. All right, so we have this Kishore is the first one. I'm going to remove this from here and just putting there in my list. And we'll be connecting Kishore on his email ID for giving in the voucher. Now the next one. All right, so it's Rahman. I'm just putting here in our list. So the okay, now let me remove this again and then put the next one. Yeah, this is the third winner. Search. So it's Rajkumar Roy. I'll be putting the name over here. And let me remove this. And fourth. So it's Navneet. Okay. I see duplicates over there. Okay. So this is the next team. It's Luis. We'll be connecting you on the next. Okay. And this will be our last winner. 6-1. All right. This is the last one. And, okay, so it's Muazzam Muhammad Khan. So we will be connecting with you on email provided by you, and we will request you to provide the name on the. All right. We will be requesting. So we have already selected the sixth one. So let me close this. And okay. So now let me share my slides again. And we will be closing the session now. Okay, so far we have discussed all the modules, and probably hopefully all these sessions that we are doing for this exam is helpful for you. If you want to connect with Sanjeev, the LinkedIn URL is there for his profile, and also if you want to connect with me, you can connect with me on the LinkedIn. Uh, you can register for all the future sessions by using this URL, https azureeasy.com/az400. That should redirect you to an Eventbrite page, and there you can register for our future sessions of this exam. We still have, this is our fifth session. We still have 3 more sessions to complete the other topics. In total, we have 8 sessions. If you have not watched our previous sessions, you can go ahead and watch our previous sessions on YouTube channel. You can also join our Telegram group, AzureTalk group, where we have more than 9,000 members helping each other to learn Azure. We have a Azure DevOps group, more than approximately 3,000 members. There we are mostly discussing things related to DevOps. So you can join our both the groups to discuss further, to understand, and if at all we are not able to cover certain questions, please post your questions over there, and we will definitely try to answer your questions over there. And hopefully all the sessions, all the topics that we are trying to cover in this format is helpful for you to cover, to take the exam, and to clear the certification and help you to grow into this industry further. uh, you can if you think, if you see our sessions are helpful for you, you can share your feedback in terms of some post or whatever the way you are posting. Just mention our Azure Talk, and the Azure Easy and Azure Talk in your mentions, so that we can track those mentions, and we can see those post, and it really kind of help us to spread the word across in the community, how our sessions are helpful to other people. Having said that, this is, we would like to conclude the session for today. uh, let's join us again in the next session, where we'll be taking further this exam with the next topic, and with all the in the same format, where we will be discussing about the concept, and we will try to couple it with some lab, where we will be demonstrating some of the practices with the demonstration as well. Thank you so much. Thank you so much for joining us, and thank you so much for supporting us. Thank you. Have a great night and good day.